Hi everyone, this is Kishore. Please subscribe my channel. Okay, today we are going to discussing about continue from the materials. Okay, coming from the materials. So generally we are discussing both conductor as well as insulator as well as semiconductor materials. All those things we are learning the before class. Okay, so let us. So in basically in any material may contains basically two bands. So one is the valency band and second one is the conduction band. Second one is the conduction bands. Two bands is there. Any material. Okay, basically either conductor or insulator or semiconductor. Okay. So coming to the valency band, okay, this is the one band, this is the another band. Okay, so two bands. Okay, so coming to the valency band, in valency band generally may contains electrons. Okay, in valency band generally may contains electrons that is indicated as generally negative polarity. That is indicated as generally negative polarity. Okay, so this electrons is called as free electron. This electrons is called as simply you can call it as free electrons. Okay, as well as coming to the conduction band, in conduction band there are different types of holes is there are different types of holes or simply holes is there. These holes can be, we can indicate as like a positive polarity. Okay, these holes also called as like a protons. This also is like a simply you can call it as protons. Okay, in semiconductor material basically you can call it as holes. Okay, so these holes can be simply you can also call it as like a proton elements also. Proton will also make it as positive polarity, so there is no problem. Okay, holes. So coming to the, so between the, so valence band and conduction band, between the valence band and conduction band, in between some gap is there, okay, some bandwidth is there. Okay, so this bandwidth is called as, simply we can call it as energy gap. Okay, or some Fermi level energy gap, or some Fermi level, or some forbidden gap. Okay, so energy gap or a Fermi level or a forbidden gap between the valence band and conduction band, some gap is there, that is called as either energy gap or a Fermi level or are also called as like a forbidden gap. Okay, so this is the general representation for the any material. Okay, either conductor or an insulator for semiconductor, either semiconductor. Okay, so coming to the conductor material. Okay, so generally we are so discussing about the, so bands clarification. So coming from the conductor material. Okay, so coming to the conductor material, so basically between the valence band and conduction band, basically between the valence band and conduction band there is no gap takes place. Okay, so here both conduction band as well as both valence band as well as both conduction band, which is simply collide to each other, simply which is collide to each other. Okay, here both holes as well as electrons both are recombination or are colliding to each other. Okay, so resultant the output current will be comes to the material. The output will be comes to the output current will be comes to the material. So that is indicated as SMI. Here the current is generally coming to the DC current. Here the current is generally coming to the DC current. Okay, so because these are the conducting material. Okay, so there is no gap, there is no energy gap, or there is no forbidden gap, or there is no Fermi level between the valence band and conduction band for the conductor material. So that's why simply here holes and electrons which is colliding. So almost, so that's why you can simply call it as the in case of conductor which can allow the flow of electrons. Okay, directly flow of electrons or a flow of charge carriers. Okay, simply. So there is no Fermi level between conduction band and valence band. So coming to the insulator. Okay, so between the valence band and conduction band, the Fermi level or energy gap is very high between the valence band and conduction band. So that is generally given as 6 electric volts. That is given as generally 6 electric volts, 6 EV, 6 electric volts between the valence band and conduction band. Okay, so that's why there is no current flowing from the, so there is no colliding ions between the both there is no colliding ions, both positive ions as well as negative ions. Resultant there is no current will be coming. Okay, in case of insulator. Okay, so there is no current will be flowing as well as, so the forbidden gap between the both valence band and conduction band is 6 electric volts, which is very high. Okay, so and as well as coming to the semiconductor material. Coming to the semiconductor material. Okay, coming to the semiconductor material. In semiconductor material, so basically between the valence band and conduction band, basically the energy gap is there, but that is low when compared to the insulator, as well as which is high when compared to the conductor. Okay, so that is, so simply the energy gap between the holes conduction band between conduction band and valence band for the semiconductor is high, so that is given as like this, that is given as like this. So when compared to insulator, which is slightly low, when compared to the conductor material, which is slightly high. Okay, so the energy gap between the conduction band as well as valence band, which is given as 3 electric volts, which is given as 3 electric volts for the semiconductor material. So that's why, so in this partially flow of current will be takes place from the semiconductor material. Why? Because whenever the, for example, let us consider the semiconductor material will be, so simply, for example, if I place in room temperature, so then only, so this layer will be breaking, then only this energy gap or this permitting gap will be breaking. Due to that, both holes as well as electrons both are colliding to each other, resultant output will be coming. Output is like a DC current will be coming. Okay, whenever the room temperature will be placing, whenever we are placing the room temperature, this material. Okay, otherwise this semiconductor acts as like an insulator. Okay, so these are the based on the, so basically characteristics of a both conductor as well as insulator as well as semiconductor material. These are the different types of properties. Okay, so thank you everyone. So for next video we are generally discussing about the, so different types of videos. So please subscribe my channel as well as please support to me. Okay, thank you very much. Thank you.